Today, we're going to learn how to use the priority queue. Hello, I'm James Helfrich. The priority queue is similar to the queue in that we can add elements in and take elements out. The difference is the priority queue always removes elements in priority order. In other words, the highest value item comes out first, then the next highest value. We'll learn how that works today.
There are four ways to create a priority queue object: the default constructor, the copy constructor, the move constructor, and the range constructor. Note there is no initializer list with a priority queue. Okay, so I want to use a priority queue, so I need to pound include not the priority queue library, but rather the queue library. Isn't that odd? Now the full name is std : priority queue, and I must specify the template parameter, which is the data type I want to include, in this case an int. And I'll call this pq for priority queue. Now when I break into the debugger, we're going to see that my size is 0, which I do expect, but notice how the underlying data structure is a heap. Okay, now let's fill this with values. Unfortunately, there's no initializer list, so I now need to specify another container to have the values, and I'll just use a list here. I could use a vector or pretty much anything, and I'll just fill it with a bunch of random integers. Now when I initialize my priority queue with those list values, I need to specify the list iterators, and I do this by passing l.begin and l.end. Now observe that the order of the values in my list are random: 4, 10, 4, 2, 7, 9, 15. But they will not be random in my priority queue itself. The highest value element must be in slot 0. Now notice once again the list is in random order, but the priority queue, size 7, which we expect, the highest value is first. The second highest value must be second or third, and so on. In other words, this is going to be stored as a heap where every element is greater than or equal to the two child elements. Okay, so now that I've initialized this, I can now have a copy constructor. So I'm going to have my pq source, which I'm coming from, and then I'm going to have my same priority queue int pq destination. Initially this will be empty. And so when I call the copy constructor, I'm going to copy all the values from the source into the destination, which means the source should have all its values still there. Oops, pq source, haha, typo. Okay, so let's run this, and we'll notice that the source and the destination will both have the same 7 elements, and the elements will also be in heap order, which means the highest element is in slot 0. Okay, I can also do std : move, which we'll call the move constructor, and this will move the elements from the source into the destination, which means source will be of size 0, and destination will now be size 7. And sure enough, source is of size 0, and destination is of size 7. Priority queue has the assignment operator, the move assignment operator, and the swap method, as well as the swap function. I'll start with my same 7 elements that I had before, and I have my source and destination. Now if I call priority queue destination equals priority queue source, then I'm going to expect that source's values will be copied in the destination, and both the source and the destination will have the same 7 elements, and they do. Now I can also call the move constructor by saying the move assignment operator by calling std move, and this will steal the elements from source and put them in the destination, which means source will be of size 0 and destination will be of size 7. And sure enough, that's the case. There we go. Okay, now I can also swap the elements, and this is really more illustrative when I have values both in the source and the destination. So I'll have list 1 will be those same 7 values, and list 2 will be a different set of values. And it doesn't matter what values we have here, I just want them to be different. And now the source is going to start with L1 and to begin to L1 end. And I'll have the destination to L2. So destination will have 4 elements and the source will have the 7. Okay. All right, so now when I run this with move, then we expect the destination's elements to be deleted and the source is 7 to come over. So destination will be of size 0 and source will be of size 0. And when I swap them, now source will be of size 4 where it used to be size 7, and destination will be of size 7 where it used to be 4. So they switch places. And sure enough, that's the case. For my initial list, which I'm not changing, to my destinations, which I am changing. There is no iterator for the priority queue. The priority queue has a single access element, top. In other words, we only have access to the topmost element. Okay, I'm going to start with my priority queue that has the 7 elements, and I'm going to say, my value equals priority queue.top, and this should give me the value 15. And why the value 15? Because it's the highest value element in the priority queue, which is the only element we have access to. We have 2 insert methods, copy push and move push. Notice we don't get to specify where in the priority queue it goes. The priority queue will determine the best position for it. All right, we'll start with the same 7 elements we have before, and we're going to say push, and we're going to pick a large value, 100. Now, since 100 is greater than anything we currently have in the queue, we expect this to be in slot 0. So when I break into the debugger, sure enough, it's in slot 0. Now let's try this again. We're going to put something that's not the largest. Let's say 11. Now 11 is the second biggest, so it should be in slot 1 or in slot 2. And when I check it, it is in slot 1. There we go. And now I'll put in a small element, the smallest element of all. It must be on the bottom row in the priority queue, which means it must be in the second half of the underlying data structure. And when I check it, we'll see that it put it in slot. Where did it put it? The very last slot. There is only one remove method, pop, and pop will remove the largest value from the priority queue. We'll start with the 7 elements from our priority queue, and when I say priority queue.pop, I will expect this to remove slot 15. And when I run it, sure enough, there's only 6 elements and 15 is absent. Okay, let's do this again, and this time I'm going to do a whole bunch of pops, one at a time. And let's see how each successive pop will modify my priority queue. Okay, so when we run it, first of all, I have the 7 slots, right? And then when I say go, then it's going to remove slot 15. So now 10 will percolate up. Good. Then I'm going to remove 10. And 10, now 9, 7, 4, 2. And then I'll remove the next one, 9. Now it's 7. In each case, I'm always removing the highest element, and then another element takes its place at the top of the priority queue. And this continues all the way until the end. There are 2 status methods, size and empty. Okay, so I have the 7 elements in my priority queue, so I expect size to be 7 and empty to be false. Remember, the data type of size is always a size t, which is an unsized integer. And I expect empty to be false, and empty returns a Boolean, true or false. In this case, it would be false. So when I run the code, we're going to notice that size is in fact 7, and empty is false, sure enough. Okay, let's do the same thing, except this time I'm going to have an empty queue. So I'm just going to use the default constructor. Now, actually, we don't use the empty parentheses for the default constructor, so I expect a compile error here. Oh yeah, so what I need to do is remove those parentheses, and when I do that, then I will get the default constructor. And size is 0 and empty is true. To learn more about the priority queue, please see Chapter 13 of the C++ Data Structures textbook.